All right. So another question we could ask when dealing with antiderivatives is, goes back to this picture we had earlier, right? So for every number I could add on to the end of this antiderivative, I got a different sort of piece of the function, right? Or a different, vertical translation here. So how can I do an indefinite integral and say, give me, this orange one here, right? How do I pick that out? Well, to do that, we use something called an initial condition. Right? So initial condition. Sometimes we'll say initial value. Right? What this is we just specify, uh, basically some particular x and y value that we want the graph to pass through. Right? So we pick some point on the plane, the xy plane, and we say, I want the antiderivative that goes through there. Right? So we say, all right, well, the initial condition f of a equals b, for example. Right? Okay, so let's look at an example of something like this. Another common way to write this is so we can write that, or we can say, solve this problem here where little f of a equals b. And there's a couple ways this problem can be presented. So here what I want to do is I want to find the antiderivative of f prime of x equals, let's say 4x squared, which is a different function here. A 4x squared satisfying the initial condition f of -1 equals 3. So how do we do this? Well, let's just start by finding a general antiderivative. So what we'll call a general solution. Right? So this is going to be f of x, which is going to be the antiderivative of this. Antiderivative of 4x squared dx. Right? So that's 4/3 x cubed c. And, right? So now that we have that, we just plug in these values here. Right? So f of -1, plug that in, we're going to get 4/3 times -1 cubed plus c. So this is -4/3 plus c equals 3. And now we just solve for c. Right? If we do that, we get that c is going to be 13/3. Right? And so this, what we're going to call a particular solution, is f of x equals 4/3 x cubed plus 13/3. And that's the answer we really want. Okay. So this kind of problem has 2 steps to it. We first want to find, well, what's the most general antiderivative of this? Right? That's what I'm calling the general solution here. And then we want to narrow down onto sort of the specific c value we need to make that initial condition happen. All right? And to do that, well, we just take this initial condition. This is the x value. This is sort of the f value or the y value. and we plug those in, right? And then solve for c. And this gives us a particular solution. So this thing up here, this kind of thing here is actually sort of a very basic form of something called a differential equation. Misspelled that a little bit. There is an A in there, right there. Oh, I didn't even spell differential right. Let's just try this all again. Differential. Oh. Right. So again, this is a very basic form of one, but this is something you'll study more in the future if you keep going with calculus.